Let's look at day 2 of this new unit. We are building on the world of imaginary numbers that we introduced last time. We are actually talking about the appropriate name for those kind of numbers, and that is complex numbers. So of course the first question is, what is a complex number? And the answer to that is, it is a number that combines a real number, like the things that we've worked with before, positives, negatives, decimals, fractions, with an imaginary number. These were the new guys that we talked about. They were the ones with the eyes. And you will always see it written in this specific form, A plus BI. And when you see that, we have two parts to it. We have A, this is the real part, and we have BI. This is the imaginary part. We know the imaginary part because it has the I, the other part's real. When you're giving me answers to these, I always expect that order. I want the real part first and the imaginary part second. What we're going to be doing today is we're going to learn how to graph these numbers, which is very simple, and we're going to learn how to add, subtract, and multiply these complex numbers. So let's take a look at graphing. When you're graphing complex numbers, you are treating it as a ordered pair. A, comma, B. The real part is the A, the imaginary part is the B. Notice I didn't worry about the I. So the x-axis, instead of being called the x-axis, it is now the real axis. And the y-axis is now called the imaginary axis. So it looks like this. We have a real axis that goes left and right, and we have an imaginary axis that goes up and down. So we're going to look at some very easy imaginary complex numbers to graph. Example 1, the first thing we want to do to graph each one of these is make them into an ordered pair. Pay attention to your positives and negatives. Pay attention to if there's something missing. So for this first one, my ordered pair would be 5, comma, 7. I just ignored the I. My second one would be -3, comma, -2. Again, I ignored the I, but notice there's some negatives in there. C is missing something. Is it missing the real or is it missing the imaginary? Well, that's 8I. That has an imaginary, which means it's missing the real. So the real part is 0. The imaginary part is 8. Now that we have these as ordered pairs, we're going to graph them like we would any ordered pair. This first one is right 5 and up 7. So go 1, 2, 3, 4, 5 to the right, and 1, 2, 3, 4, 5, 6, 7 up. Now we're going to put all of these on the same grid, so we want to label it. So next to that dot, write 5 plus 7I, because that's what the problem was. Second one, negatives. So we're going to go left 3 and down 2. Back to 0, left 3, down 2, put a dot, label it -3 minus 2I. Finally, the last one, 0 left and right, 8 up. 0 left and right, and 1, 2, 3, 4, 5, 6, 7, 8 up. Put your dot, label it 8I. What do we think? Pretty easy there? I would think so. So the next thing we're going to do is we're going to look at the rules for adding and subtracting together. So our adding and subtracting rules say that we are first going to distribute, you guys know what that means, multiply, any subtraction signs. Then combine like terms, which we have done very many times before, and make sure that your final answer always has real first, imaginary second. So let's look at this first problem. This is an addition problem. There is no subtraction signs to distribute, so I'm going to keep it as 5 plus 3i plus negative 2 minus 4i. I'm going to combine the real and the real. 5 and negative 2 make positive 3. I'm going to combine the imaginary and the imaginary. 3 and negative 4 make negative 1i. That is a done answer. If you do the reals first and the imaginary second, you will always keep it in the proper form. B, on the other hand, is a subtraction problem. So this is where we need to distribute. So what this means, the first parentheses do not change. The second parentheses, I am going to do the opposite of both numbers. The opposite of negative 3 is positive 3. The opposite of positive 7 is negative 7. You just do the opposites of anything after the subtraction. Now we are ready to combine like terms. Real and real. 4 plus 3 is 7. Imaginary and imaginary. Negative 10 and negative 7 make negative 17i. What do we think? Is adding and subtracting pretty easy? So what I would like you guys to do, press pause, try these 3, unpause it to see how you did. So let's see how you guys did. This is a subtraction problem. Keep the first set the same. Do the opposite. The opposite of positive 5 is negative 5. The opposite of positive 5 is negative 5 again. Real and real make negative 11. Imaginary and imaginary make negative 18i, and that is a done problem. Over here, that's an addition problem. No need to distribute, just drop the parentheses. If we're looking for the real parts, there is only one real part, so it's 4. There are 2 imaginary parts. Now this is an I. What's in front of him? A 1. So 1 minus 6 is negative 5i. Hopefully you got that one right. Finally, I look. The first thing I see here is addition. So I'm going to drop the parentheses because nothing needs to be changed. But this is a minus 3i, so we are doing some subtraction as well. Look for all your real parts. 3 and positive 4 make positive 7. There are 3 imaginary parts. Positive 2 minus 9 is negative 7. And then we're going to subtract 3. Put it all in your calculator. 2 minus 9 minus 3, and you should end up with minus 10, and the I tags along. And that is a done problem. What do we think? Is adding and subtracting pretty easy? I mean, really, it's distributing a negative sign and combining like terms like we've done before. So now let's look at the slightly more complicated part. This is the multiplying part. When you are multiplying complex numbers, the first thing we do is distribute. In other words, we're going to do a whole bunch of multiplying. We again combine like terms, and again we write our answer in a plus bi form. However, you're going to see something new pop up. You're going to see an I squared pop up in these problems. An I squared is never allowed to be in your answer. So we need to know what I squared is equal to. Here's something you have to have memorized. Super duper important. I squared is equal to negative 1. Put stars around it, highlight it, whatever you need to do, you must know that. So let's take a look at how we multiply. So the direction said distribute. So that's exactly what I'm going to do. 5i times 2 is 10i. 5i times positive 3i is positive 15, but I times I is not I. It is I squared. So when we look at that, the part of the problem that is not allowed to be there is the I squared. 10i, perfectly fine. The 15 is perfectly fine. But instead of I squared we know is negative 1, so I'm going to change that to multiplying by negative 1. So now I have some more simplifying to do. Keep the 10i. 15 times negative 1 is negative 15. Is this an acceptable answer? Well, sort of. It has everything we want, but it is not in the right order. We want the real part, the minus 15, first, and we want the imaginary part, the positive 10i, second. That is a done problem. Now that was a simple distributing problem. It had one item to be distributed. If you look at B, there are multiple things here. I don't want you to get confused. This is not meant to be difficult. We're going to take the negative 7 and distribute it first. Negative 7 times 9 is negative 63. Negative 7 times, this is a negative 1i. So negative 7 times negative 1 is a positive 7i. Now all we're going to do is distribute again, but now with the minus 6i. Minus 6i times 9 is minus 54i. And negative 6 times negative 1i is positive 6i squared, because there's two i's there. So now, let's take a look at what's next. We have to combine like terms, and we also have that I squared guy that's a problem. Well, we can do a couple of things at one time. Is there anything I can do with the negative 63? No. Is there anything I can do with 7i and negative 54i? Absolutely. I can combine those. 7 take away 54 is negative 47. Is there anything I can do with the positive 6i squared? Yeah. We can keep the positive 6. We don't like I squared. We're going to change it to times negative 1. Is this a done problem? No. We have to do our multiplying. Keep the negative 63. Keep the 47i. 6 times negative 1 is negative 6. Well, now are we done? No, because we have two real numbers. So we are going to combine the negative 63 and the negative 6 to make a negative 69 and bring down minus 47i. And we are done. So multiplying is much more steps than adding and subtracting. Let's do this. I want you to pause the video and only do 5a by yourself. We'll do 5b because there's more steps. Okay, so let's see how you did on 5a, because it was just like 4a and b. Distribute. We're going to start with the 2. 2 times 5 is 10. 2 times minus 4i is minus 8i. And then we come to the 3i. Positive 3i times 5 is positive 15i. And positive 3i times negative 4i is negative 12i. I squared. Now we're going to do some multiple steps at one time. Nothing I can do with 10. Negative 8i and positive 15i make positive 7i. Negative 12 is okay, but I squared changes to times negative 1. Now we got to multiply. Keep the 10, keep the 7i. Negative 12 times negative 1 is positive 12. Use those negative signs. Finally, 10 plus 12 is 22 plus 7i. How'd you do by yourself on that one? Hopefully you got the right answer. Let's look at B. B is a toughie because there's an extra step. So here's what I tell people. Pretend that the I, pretend this guy right here is not there. Cover him up with your hands and do the parentheses like we just did 5a. So 2 times 4 is 8. 2 times 3i is positive 6i. Negative 5i times 4 is negative 20i. Negative 5i plus 3i is negative 15i squared. We are still ignoring that I. Keep going. Keep the 8, positive 6, and negative 20i make negative 14i. Keep the negative 15, but change I squared to negative 1. Keep going the way we've been doing. Keep the 8, keep the negative 14i. Negative 15 times negative 1 is positive 15. And 8 plus 15 is 23 minus 14i. That is the part that you're comfortable with. Now we have to deal with this other guy. So here's what's going to happen. We're going to put this in parentheses, and we're going to bring that other I all the way down here. So now we have to distribute again. I times 23 is 23i, and I times negative 14i is negative 14i squared. Is that an acceptable answer? No. We got to get rid of I squared. Keep the 23i, keep the negative 14, change that to a negative 1. 23i, negative 14 times negative 1 is positive 14. And now the only thing we have to do is write it in the proper order. 14 comes first, positive 23i comes second. That's your super challenge one. Okay, you'll probably see one like that on the homework, but that is meant to be your challenge question. So turn to the next example. I would like you to pause the video and multiply all three of these problems and see if there's anything you notice. You should notice something about all the answers. So you pause the video and work through those. Okay, so let's see how you did on these. 2 times 2 is 4. 2 times minus 3i is minus 6i. 3i times 2 is positive 6i. And 3i times negative 3i is negative 9i squared. Okay, so moving on. Keep the 4. What happens when you do negative 6i and positive 6i? What's a negative 6 plus 6? Well, it's 0. Well, if it's 0, what that means is those two really cancel. Don't write 0i. Cross them off. Now this last part, we like the negative 9, but we don't like the I squared, so I'm going to make it a negative 1. Keep the 4. Negative 9 times negative 1 is positive 13. And 4 plus 13 is 17. Interesting. I'm sorry. I made some major mistakes. I can't do anything in my head. Negative 9 times negative 1 is positive 9. I'm sorry, I was thinking ahead. 4 plus 9 is 13. So, notice there's no i's in that answer. Well, let's look at B. 6 times 6 is 36. 6 times positive 11i is positive 66i. Negative 11i times 6 is negative 66i. And negative 11i times positive 11i is negative 121i squared. 36 we keep. Positive 66 and negative 66 cancel. Negative 121 we're okay with, but I squared we change to negative 1. 36, negative 121, and negative 1 make a positive 121. And 36 plus 121 is 157. Final example. Negative 4 times negative 4 is positive 16. Negative 4 times negative 1i is positive 4i. Positive 1i times negative 4 is negative 4i. And positive 1i times negative 1i is negative 1i squared. Keep the 16. Positive 4i and negative 4i cancel. We like the negative 1, but the I squared, we change to times negative 1. Keep 16. Negative 1 times negative 1 is positive 1. And 16 plus 1 is 17. So what did you notice about all three parts here? What did you notice about all of their answers? The correct answer should be all answers were real numbers. In other words, there is no i's left. That's not a coincidence. These problems are what we call conjugate pairs. If you look at the problems, 2 plus 3i, 2 minus 3i. 6 minus 11i, 6 plus 11i. Negative 4 plus I, negative 4 minus I. If you notice, the numbers are the same in both parentheses. The only thing that changed on each problem was that plus became a minus. That minus became a plus. That plus became a minus. All that changed was the imaginary part flipped. Nothing else. The reason I wanted to introduce this today is because this is going to be very important in the next lesson. You're going to hear the term conjugate pairs, and so you need to know to take the real part and do the opposite, and you will be perfectly fine. So go ahead, you can start on homework. I'll see you next class.